And now we are coming to exercise 3.2, 2.2, sorry, not 3, 2. Exercise 2. In this exercise, we have to find the zeros and as well as the relationship between the zeros and coefficient of a polynomial. So let me explain the standard form of quadratic polynomial. Quadratic polynomial means it should be ax square plus bx plus c because it is quadratic. So there must be 2 degrees. So the standard quadratic polynomial is ax square plus bx plus c. Okay. So whenever the question is in the form of quadratic, so we will, by the help of factorization, we will find their value of x, that is called zeros of the polynomial. And after getting the zeros, we will find it with the relationship. And the relationship says, okay, what is the relationship? Sum of zeros, sum of zeros, say alpha and beta, okay, let alpha and beta are the zeros, alpha plus beta is equals to minus b upon a. Now, what is b and what is a? B is the coefficient of x and a is the coefficient of x square. So for your information, I am writing here a minus coefficient of x upon coefficient of x square. So this is minus b upon a, sum of the zeros. And product of zeros, that is alpha beta, and this is equals to c by a. So what is c? C is the constant term, right? C is the constant term and a is the coefficient of x square. So after getting the value of zeros, we will verify with this relationship, right? Okay. So for example, I am taking an example and then I will switch over to your exercise. Okay. So suppose the question is 2x square minus 8x plus 6, right? 2x square minus 8x plus 6. This is the given polynomial. Okay. So first of all, we will, what we have to do, we will factorize it. Okay. 6 to the 12 and 6 to 8. So this can be written as 2x square minus 6x and minus 2x and plus 6. Now take 2x as common. So what is left? X minus 3, and here minus 2 is coming common. So what is left? X minus 3. So x minus 3 is again common and 2x minus 2. Okay. After that, don't put directly x minus 3 is equals to 0. Okay. Because it is the case of quadratic polynomial. So here we will write a simple language. A value of 2x square minus 8x plus 6 is 0 when either this factor x minus 3 is equals to 0 or 2x minus 2 is equals to 0. So here x is equals to 3 and here x is equals to 1. So we got the two zeros. One zero is 3 and second 0 is 1. So this, suppose this 0 is, you may indicate by alpha and you may indicate by beta, and now we will verify it with the relationship, right? So find the value of a, b, c. So here the value of a is equals to coefficient of x square, that is 2. The value of b is coefficient of x, that is minus 8, and the value of c is 6. So first find the value of a, b, c. And now verification. Start verification. Verification. A sum of zeros that is alpha plus beta is equals to minus b upon a. So the alpha value is 3, okay, and beta value is 1, and minus the value of b is minus 8, and the value of a is 2. So left side 4, and minus minus plus 8, and 8 divided by 2, that is 4. So LHS is equals to RHS. It means it is verified. Okay, and now find product of zeros. So product of zeros, that is alpha beta, is equals to, as per the relationship, C by A. So the value of alpha is 3 and the beta is 1 and the minus constant is 6. Okay, constant is plus 6, that is alpha beta, that is C by A. So here will be B is 6, and what about A? A is 2. So 3 ones are 3 and 2 threes are 6. So it is again very wide. Okay, got it? So in this way, we will simplify the exercise. Okay, now I am coming to the exercise. Okay, and in the exercise, there are two types of question. You find the zeros of the quadratic polynomial and verify the relationship between the zeros and the coefficient. And the second type of question is the sum of and product of the zeros are given, then find the quadratic polynomial. Okay, so I am taking exercise 2.2, the very first question. Okay. Exercise 2.2, question number first, and the first part. And the first part is x square minus 2x minus 8. This is the quadratic polynomial. Okay. So start factorization. 8 ones are 8. We want 4. 4 twos are 8. So this will be x square minus 4x and plus 2x and minus 8. Now take x as a common. So x minus 4 and plus 2 as a common. X minus 4. So x minus 4 is again common, and x plus 2. So we got these factors. Now we will write a language. The value of x square minus 2x minus 8 is 0. Okay, when either x minus 4 is equals to 0 or x plus 2 is equals to 0. So here x is equals to 4 and x is equals to minus 2. So say this is alpha and this is beta. So we got the zeros, and now we will start verification. So for the verification, here the value of A is 1 and the value of B is minus 2 and the value of C is minus 8. We got the value of ABC, and start verification. Sum of zeros with the relationship sum of zeros, that is alpha plus beta, which is equals to minus b upon a, and the alpha value is 4 and the beta value is minus 2, so plus minus minus, and this is minus b, and the b is, what is b? Minus 2, and what is a? A is 1. So 4 minus 2 is equals to minus minus plus 2, hence it is verified. Okay, now the product of zeros, that is alpha beta, and the relationship says C by A, and the alpha value is, what is the alpha value? That is 4, and the beta value is minus 2, and the constant is C is coming minus 8 and A is 1. So it is minus 8 is equals to minus 8, and hence it is also verified. So in this way we will find the zero and we will find its verification. Okay, now I am taking the third part. Second part you will try yourself. Third part I am taking 6x square minus 3 and minus 7x. This is the question. So first rewrite the question, arrange the question as per the degree. Degree should be always in descending order. So this is 6x square minus 7x and minus 3. Okay, 6 3 is 18. So 9 and 2 will be the factor. So 6x square minus 9x plus 2x minus 3. So now here is 3x is coming common. 3 2 is 6x and minus 3. And plus 1 is coming common. So 2x minus 3. So 2x minus 3 is again common and 3x plus 1. Right? Now we will write a value of 6x square minus 7x minus 3 is 0 when either 2x minus 3 is equals to 0 or 3x plus 1 is equals to 0. So 2x is equals to 3, x is equals to 3 by 2 and 3x is equals to minus 1. So x is equals to minus 1 by 3. So say this is alpha and this is beta. Okay, this is alpha and this is beta. So now we will start verification. So for the verification, find the value of a, b and c, right? So as per this quadratic polynomial, the value of a means coefficient of x square, that is 6, and the value of b means coefficient of x, that is minus 7, and the value of c is equals to constant term minus 3. Okay, and now sum of the zeros. Sum of zeros, that is alpha plus beta, is equals to minus b upon a. The alpha value is 3 by 2 and the beta value is minus 1 by 3. Okay, and here minus, and the value of b is minus 7 and the value of a is 6. So the LCM of this side 3 to 6. So 9 minus 2 and this is 7 by 6. So 9 minus 2, 7 by 6 is equals to 7 by 6. So sum of the zeros verified. Okay, and now verify product of the zeros. Product of zeros, that is alpha beta, and this is equals to c by a, and the alpha is 3 by 2, 3 by 2, and the beta is minus 1 by 3. Okay, is equals to, the constant value is minus 3 and the constant value of a is minus 3. So minus 3 and the value a is, what is a? A is 6. So here this 3 and 3 will cancel out. So minus 1 by 2 and this is also equal to minus 1 by 2. Hence it is verified. Okay. So in this way we will verify the, after finding the zeros with the relationship. Okay. So now I will take two more questions of this exercise, that is fourth part. Okay. So the fourth part I will take the fourth part, and the fourth part is 4u square, 4u square plus 8. Okay, so here this, there is no three terms, there is only two terms. So first we will see the common. So what is common? So 4u is coming common. So what is left? U plus, okay, this is u plus 2, u plus 2. So anyhow we got the two factors. So we got the factors. So value of 4u square plus 8u is 0 when either 4u is equals to 0 or u plus 2 is equals to 0. So here u is equals to 0 by 4, that is 0, and here u is equals to minus 2. So one is alpha and another one is beta. And now find the verification, right? Verification. So the value of A is means the coefficient of u square, that is 4, and the value of B is coefficient of u, that is 8, and there is no constant, so we will get, okay, because there is no constant term. So sum of zeros, that is alpha plus beta, which is equals to minus b upon a. Put the value of alpha and beta, and alpha is 0 and beta is minus 2, okay, and minus b means minus 8 by 4, okay, minus 8 by 4. Sorry, b is plus 8, not minus 8. The value of b is positive. So 8 by 4. So this will be minus 2 and minus 4 to z minus 2. So it is verified. Okay. Now product of zeros. So product of zeros, that is alpha beta, which is equals to by a, the product of zeros, and the value of alpha is, what is the value of alpha? 0, and the value of beta is minus 2, and the constant term is 0, and the a value is 4. So 0 multiplied with minus 2, 0, and 0 divided by 4, 0. So it is also verified. Okay, got it? And the fifth part, I will take the fifth part, and sixth you will try by splitting the middle term. Okay. So the fifth part, and the fifth part is t square minus 15, t square minus 15. Okay, so now we will make it identity. How? So this can be written as t square, and this is root over 15 whole square, value will not be changed, and now it is the form of a square minus b square, and a square minus b square is equals to a plus b, okay, into a minus b. So we got the factors. So value of t square minus 15 is 0 when either when either t plus root 15 is equals to 0 or t minus root 15 is equals to 0. So t is equals to minus root 15, and here t is equals to plus root 15. So this value is alpha and this value is beta. Okay, and now start verification. So for the verification, find the value of a, b, c. So a is coefficient of t square, that is 1, and there is no coefficient of t, so b will be 0, and the value of c is minus 15. Okay, now verification. So sum of zeros, that is alpha plus beta, write the relationship minus b upon a. Alpha value is minus root 15 and beta value is root plus 15, and minus b is 0 and a is 1. So this will be 0 because this and this will cancel out, plus minus, and 0 by 1 is 0. So it is verified. Okay, and now product of zeros. So product of zeros, that is alpha beta, is equals to by a. So the alpha value is minus root over 15 and the beta value is root over 15. Okay, the value of beta is root over 15, and the c value is minus 15 and the constant a is 1. So after the multiplication, the root over 15 into root over 15, that is minus 15, and this is also minus 15. So it is verified. Okay, got it? So in this way, we will find the factors first, and after getting the factors, we will write the value of this polynomial is 0 when either this factor is 0 or this factor is 0, and then find the two factors, find the two zeros. Suppose one is alpha and another one is beta, and then find the value of ABC from the given quadratic polynomial and apply the for relationship formula and verify it. Okay. So for the next question, I am taking question number 2. And the question number 2 is formation of quadratic equation if the sum of the zeros and product of the zeros are given. Okay, so I will explain with the two methods. Okay, and whichever is easy for you, you may apply either the first method or the second method. Okay. So formation of quadratic polynomial, formation of quadratic polynomial when the sum of the zeros and product of the zeros are given, right? So there are two ways find the value of to form a quadratic equation. First method is the quadratic formation, the quadratic polynomial is x square minus sum of zeros sum of zeros into x plus product of zeros, right? With k times here we will write. Why I am writing k here, that I will explain. In, or you may write in the short form k is equals to the quadratic polynomial is quadratic polynomial is k times x square minus sx plus, right? So S stand for sum of the zeros and P stand for product of the zeros. Okay. Suppose the first part I am taking, question number 2, the first part is sum of the zeros. Sum of zeros is equals to 1 by 4 and product of zeros is given 1, right? Sum of the zeros and product of the zeros are given. So product of the zeros is minus 1. Here it minus 1. Okay. Here it is product of zeros is minus 1. So first I am simplifying with this method. So quadratic polynomial is k times x square minus sx plus. So S stand for sum of the zeros and P stand for product of the zeros. So it is k times x square and sum is given 1 by 4x and product is given plus minus 1. Okay, so after putting the values, but it should be in the standard form, means in this form ax square plus bx plus c. This is our standard form of quadratic polynomial. So this can be written as k into the 4 will be the LCM. So then 4x square minus x minus 4. So therefore the required polynomial, quadratic polynomial is 4x square minus x minus 4, and where k is equals to this 4. So that's why we have to write k, because sometimes the sum is given in the form of rational number, okay, and the sum is not given in the form of rational number, in the form of integers, then k will be equal to 1. Okay, so this is the one way to solve. Another way, I will solve with the help of relationship. Okay, a sum of zeros, this is given 1 by 4, and the sum of zeros is minus b upon a. Okay, and product of zeros is given minus 1, and this is equals to by, right? So make the denominator equal. Here b is minus 1, b is 1 here, and a is 4. In the denominator is 4, here is 4. So can we write minus 1, can be write minus 4 by 4? Okay, make the denominator equal. So the value of a is equals to 4. The value of b is minus 1. The sign will be with integer only. And the value of c is equals to minus 4. So we got the value of ABC. Okay. So the quadratic polynomial, that is ax square plus bx plus c, and now put the value of ABC. The value of a is 4x square, and the b is minus 1 into x, that is x, and c is minus 4. So in this way, we got the same answer. Okay, so either you may apply this method or you may apply this method, as you like, and both the methods are correct, even given your in your question book also. Okay, now I am taking the question number 2, second part of this question, formation of quadratic polynomial. Okay, so I will go with the this x square k times x square minus sx plus p method only. Okay, for the second method, if it is easy for you, then you may apply the second method. Okay, it is up to you. Either you can solve by this method or this method. Okay, so the second part is the sum of zeros is equals to root 2, and product of the zeros is 1 by 3, and product of zeros, this is 1 by 3. Okay, so quadratic polynomial, we will write quadratic polynomial is k times x square minus sx plus p. Okay, so this is k times x square, sum is given root, so root 2x, and product is given 1 by 3. Now take the LCM. So 3 is the LCM. So this is 3x square minus 3 root 2x and plus 1. So the required polynomial, therefore quadratic polynomial. What will be the quadratic polynomial? That is 3x square minus 3 root 2x plus 1, and where k is equals to 3. Okay, so this 3 and 3 will cancel out, right? So this is the required quadratic polynomial. Okay, then I am taking the third part, of this question, and the third part is given a sum of zeros is given 0, and product of zeros is given 1 by 4, root 5. Product of the zeros given root 5, root 5. So the quadratic polynomial, that is a times x square minus sx plus p. So k times x square and sum is given 0 into x and product is given root 5. So this is k times x square. 0 into x means 0. So x square plus root 5. So the required required quadratic polynomial is x square plus root 5, and where k is equals to 1. Okay, k is equals to 1. So in this way you will simplify the form the quadratic polynomial if the sum of the zeros and product of the zeros are given. Okay, and rest of the question you will solve. Okay, now one point which is not given in your book. Okay, and the question may be asked with the case of alpha and beta. Okay, how you will find this, and this is the last point, and this your chapter will be over. Let me discuss this. Okay, that is question based on symmetric function, it is called. Okay, find the value of, if alpha and beta are the zeros of the polynomial, then find the value of 1 upon alpha plus 1 upon beta, or 1 upon alpha square plus 1 upon beta square. So for this type of question, I am writing a formula, because our solution is in the form of product of zeros and sum of zeros. So first, then we will find alpha plus value of alpha plus beta and alpha beta. Okay, so alpha square plus beta square is equals to alpha plus beta whole square minus 2 alpha beta. Actually, it is not the new identity. It is not the new identity, as you already read in the previous classes, that is a plus b whole square is equals to a square plus b square plus 2ab. So when you will open it, a alpha square plus beta square plus 2 alpha beta and minus 2 alpha beta, that will be cancelled out. So it is equals to alpha square plus beta square. So write in this form. Why? Because we are having sum of the zeros and product of the zeros. So this is the value of alpha square plus beta square. Okay. Then alpha square, say alpha minus beta, if it is given whole cube. So this can be written as alpha plus beta whole cube. Okay. And minus 3 alpha beta into alpha plus beta. Okay. Yeah, alpha minus beta, alpha cube beta cube plus 3 alpha beta into alpha beta. So in this form you will write then the value of alpha minus beta whole cube. Okay. Or if you have to find the value of alpha square minus beta square, so this is alpha minus beta into alpha plus beta. And now find the value of alpha minus beta. So alpha minus beta whole square is equals to alpha plus beta whole square and minus 2 alpha beta. So value of alpha minus beta is equals to, or this you can leave it. Sometimes it is not applicable. Okay. And so alpha minus beta is equals to root over alpha plus beta whole square and minus 2 alpha. Okay. So suppose the question is, okay, the question is given 2x square plus 3x and say minus 5, and alpha and beta are the alpha and beta are those of this quadratic polynomial, then evaluate 1 upon alpha plus 1 upon beta. Okay, this is the first part. Second part is 1 upon alpha square plus 1 upon beta square. Okay, so from this given polynomial, okay, alpha and beta are the zeros. So we will find the value of alpha plus beta, and we will find the value of alpha beta by using the relationship. So here alpha plus beta is equals to minus b upon a, so minus 3 by 2, and alpha beta is equals to c upon a, so this is minus 5 by 2. So we got the value of alpha plus beta, we got the value of alpha beta, and now starting first part, 1 by alpha plus 1 by beta. Take the LCM. Alpha beta is the LCM. So this will be beta plus alpha, and put the value of alpha beta or alpha plus beta and alpha beta. So this is minus 3 by 2 and alpha beta is minus 5 by 2. So this will be 2 and 2 will cancel and minus minus cancel. So the value of this is 3 upon 5. Okay. In the second part, in the second part, in the second part is find the value of alpha square plus beta square. So here the LCM is alpha square beta square. Then it will be beta square plus alpha square or alpha square plus beta square, doesn't matter. Now apply the formula. So this is alpha plus beta whole square and minus 2 alpha beta upon alpha beta whole square, and now put the value of alpha plus beta and the value of alpha beta. So alpha plus beta is, this is equals to minus 3 by 2 whole square and minus 2 alpha into beta, that is minus 5 by 2, and divided by minus 5 by 2 whole square. And now simplify, this is 9 by 4 and this minus minus will plus, and this 2 and 2 cancel, plus 5 divided by 25 by 4. So finally 4 is the LCM. So 9 plus 4 5 is 20 upon 25 by 4. This will be cancelled out. So the final answer is 29 by 25. So in this way you can simplify this type of question if the question comes like that. Thank you very much. And we will, if you are having any type of doubt, so please write in your comment section. I will try to resolve your issue or problems. Thank you very much.